All right, today we're going to be finding all the real zeros of polynomials. So we'll start here where it says, use the factor theorem to determine whether the function f of x equals 2x cubed minus x squared plus 2x minus 3 has the following factors. And so last class we learned that it is a factor if there is no remainder. So the first thing we would want to know is this a factor? We would want to check that using our synthetic division. So my root here is 1. So I'm going to go ahead and put that in the top corner, and then I'm going to use my coefficients. So 2, -1, 2, and -3. I drop the first term, and then we're going to multiply to get the next line here. So 1 times 2 is 2. We add as we come down, so that's going to be a 1. Multiply 1 times 1, add vertically, and then we multiply and add. And so there is no remainder on this. Our remainder is 0. So we know that this is a factor. That tells me that 1 is one of our roots for this polynomial right here. So we've got this polynomial, x minus 1 is one of my factors, so 1 would be one of my roots. All right, we're going to do the same thing here for this second one, and so -2 would be what makes that 0, so that's what's going to go in that top. And then again, I'm going to use my coefficients of 2, -1, 2, and -3. I drop my first one, I multiply, add, multiply, add, multiply, add. In this case, we have a remainder of -27. That tells me that this is not a factor. And so -2 would not be our root for this polynomial. All right, now we're going to go over to 2 there. And it tells us to factor this, given that x equals -5 is a 0, find the remaining zeros. So we're going to use the synthetic and long division that we learned in order to find all of the zeros of this polynomial. Since this is not something that you can factor the way it is, if we use this 0 that we know and synthetic division, we might be able to take it down to something we could factor. So I put the -5 in the top square. Notice that I am using -5 because it told me that is a 0. So in the cases up here, they were giving me a factor, so I was finding the root. 1 minus 1 makes that 0, but here they're giving us the actual 0, so that's the one I'm going to use in that top box. Then I use my coefficients, so 1, 3, -13, and -15. I'm going to do that synthetic division like we did before. And I get my remainder of 0. Now, I knew it was going to be 0 because it already told us that is definitely one of the roots. So we knew the remainder came out to be 0. If it came out to be something else, then we know we made a mistake because that is a 0. It told us that. And so when we have x cubed here, we know that this is the coefficient for x squared. So this would be x squared minus 2x minus 3. So I'm going to write that again over here so we have this. Now this is a quadratic, and everyone should be able to factor a quadratic, especially with the a value of 1 here. So this is one of the easier ones to factor. That's when we take it and we put it into the 2 parentheses. To get x squared, that's x times x. And then we're looking for what multiplies to be -3 and adds to be -2. And that is a -3 and a +1. Now, if this question was asking for the complete factorization, we can write that out now. We have our x minus 3 we just found and our x plus 1. And then we have the one from the original one. We knew that the 0 was -5, so this would be x plus 5. So this right here is the complete factored form. Now the question said, though, find the remaining zeros. And so x equals 3 would be a 0 because 3 minus 3 makes that first parenthesis 0. And -1 would be a 0 because -1 plus 1 makes that 0. Remember, our factors are always written as x minus my first root, x minus my second root, x minus my third root there. That's how you get those. All right, for our next one, we're going to step it up a little bit here. It gives us this longer polynomial. Again, we can't factor it the way it's written here, but it gave us two of the factors already and are asking us for the remaining factors. So we can start with this to take this down to something we can factor. It's not factorable the way it is, but we can get it there. I start with the 2. 2 minus 2. And really, you could start with either one. So if you wanted to start with a -3, you could. But I'm going to go ahead and start with the first one that's there. So 2 is my first root. And then I'm going to put my coefficients. I drop my first term. I multiply, add, multiply, add, multiply, add, multiply, and add. Again, we got a remainder of 0, and that's because it was a factor. It told us it was a factor, so we knew that it was going to come out to be 0. Now, we started with an x to the 4th here, so this would be my coefficient for x cubed. That's still something I'm not going to be able to factor. So I want to use the second factor they gave us to go ahead and do that again. If I do the synthetic division again, I will take it down to an x squared. Because if this is x cubed and I divide it by another linear factor, it's going to go down to the x squared. So I'm going to use the -3 now, the other root, and go ahead and use these coefficients here for the x cubed. And I just put that on there just to remind us that that's the x cubed there. And so I drop my first term, and then I multiply, add, multiply, add, multiply, and add. And again, it came out to be 0 because it was a factor. And so in order for it to be a factor, the remainder has to be 0. So now this was x cubed, so this is going to be my x squared here. I'm going to go ahead and write it here. And so that's something that we can factor. We've taken it down from the quartic that it was to a cubic to then a quadratic, which is something that we can factor. So we go ahead and factor our x times our x would give us x squared, and then -5 and -1. -1 times -5 gives me a +5, and -1 plus a -5 gives me a -6. All right, so for our complete factorization, I need all of the factors. So they gave us x minus 2, they gave us x plus 3, we just found x minus 1, and we just found x minus 5. This would be the entire factorization. If I multiplied x times x times x times x, I would get that x to the 4th. And then if we wanted to go further and get our zeros, then we find what makes them 0. And so we've got 2 would be my first one, -3 would be my second one, 1 would be my third one, and 5 would be my fourth one. All right, on the bottom here, we're going to talk about the theorem, the rational zeros theorem. It tells us let f be a polynomial function of degree 1 or higher in this form. And so that's just the standard form of a polynomial, where it's got the coefficient and then the x term raised to the power, and we do try and keep that in order from greatest exponent to the lowest. It says where each coefficient is an integer. If p divided by q in lowest terms is a rational zero of f, then p must be a factor of a sub 0, and q must be a factor of a sub n. So that's this coefficient, and then our constant. What this rational zeros theorem tells us is all of the possible roots. It is not giving us every single root, it's just giving us what where our roots could be found. So what we do, here's an example of one. We want to find all the possible rational roots. That doesn't mean they're all roots, it's just the possible ones. And we are going to use the p and the q to find that. And so the p is this constant. It's the factors of that constant. And so to get 6, I would need both the positive and the negative. And that would be 1, 2, 3, and 6. 1 times 6, 2 times 3, those are all of my factors of 6. The q is the coefficient of the highest degree term right here. So that would be -2. This one's a little bit easier. The only factors of 2 is 1 and 2. And so if I take P and divide by Q, that is going to give me all of the possible rational roots. And so again, we need that plus or minus because a positive times a positive gives us a positive, and a negative times a negative gives us a positive. And so we take each one of these p-values and we divide it by q. So 1 divided by 1 is 1. 1 divided by 2 is 1/2. Then I do the same thing for the 2. 2 divided by 1 is 2. 2 divided by 2 is 1. I've already put that one here, so I don't need to put it again. 3 divided by 1 is 3. 3 divided by 2 is 3/2. And then we're going to do the 6. 6 divided by 1 is 6. And 6 divided by 2 is 3. That one's already right here, so I don't have to put it. So all of my roots are going to be found right here. All the real roots are going to be found as one of those right there. Now, looking at this polynomial, we see that 4 is the highest exponent. So we know that this polynomial at max has 4 roots. So if it has all 4 real roots, they would be found in this list of roots. Now we're going to do 2 examples of what that would look like for a question. It tells us steps for finding the real zeros of a polynomial function. Use the degree of the polynomial function to determine the maximum number of zeros. Remember that highest exponent tells you that. So this one I know would have 3 at max zeros, and this one would have 5 at max zeros. Then it says, if the polynomial function has integer coefficients, use the rational zeros theorem to identify those rational numbers that potentially can be zeros. Again, potentially, that doesn't mean they're all zeros. Those could be the potential zeros. Step 3, graph the polynomial function using a graphing utility to find the best choice of potential rational zeros to test. And then we use the factor theorem to determine if the potential zeros are zeros. All right, so here we go. We take our P, which is 6 in this case, and we take our Q, which is 2, and we write all of their factors. So we just did this one on the other side, so it's pretty easy. Happens to be the same numbers. And so we said that P over Q was 1, 2, 3, 6, 1/2, and 3/2. So that's all of our potential zeros there. Now you're going to want to either graph, or you want to think about this thing, or you can just start from any one of those numbers. But we know our solutions are right here. I'm going to go ahead and start with 1 so we can see what that looks like. So my first root I'm going to try is 1. And so I used my coefficients. This came out to be 0. So now I know that's a factor. So I know that's one of my zeros now. And since this was a cubic, this is my quadratic here. So I have 2x squared plus 13x plus 6. That's a quadratic that we can factor. You guys learned in Algebra 1 how to do that with the box. And then in Algebra 2, you used a variety of different methods, slide and divide, X method, the CAB method, all kinds of different methods. So you can choose which method you want to do, but you should be able to factor this quadratic. So I'm going to go ahead and do slide and divide. So I slide my 2 to the end, and I get x squared plus 13x plus 12. Again, we have to use a method because the a value is not 1, it's 2. Then I factor, now that the a value is 1, so I do x times x, and I'm looking for what multiplies to be 12 and adds to be 13, and that is 12 and 1. Now we slid that 2 over here, so now we need to divide that 2 out since we multiplied it to the end there. This divides evenly, so I'm going to keep that as x plus 6. This one does not divide evenly, so I know that's my coefficient. That 2 becomes the front of the x there, so that's 2x plus 1. So we found one 0 right here. Here's another 0 at -6. Notice that that is a part of my list here, -6. And then we can get another 0 here. I take that 2x plus 1 and set it equal to 0. I subtract the 1 and divide by 2. And so x is equal to negative 1/2. Notice that that is part of my P over Q as well, negative 1/2. So all of my solutions are found right here. They are not all solutions, but any solution that it is going to have is going to be in that list. And so now we found our 3 zeros. And x equals 1. Now, I know those are all 3 of them because this is a cubic, and that at most has 3 zeros. So once I find the 3, then I'm done. We got lucky because this first one worked as a factor. If it didn't work, we would have to try another one. So I'll give you another example here. All right, so our P on this one is 48. Unfortunately, this one has a lot of factors. So 1, 2, 3, 4, 6, 8, 12, 24, and 48 are all factors of 48. We do the same thing for 1, and that one's real easy. That's just 1. So P over Q would just be all of these P values, because anything over 1 is just itself. So I'm not going to go ahead and write them again. I'll just write P. All of these are the list of factors. So just like last time, I'm going to start with the 1. And so I get 1, -1, -4, 8, -32, and 48. Those are my coefficients. I multiply, add, multiply, add, multiply, add. And I keep going with that. And I get to this point. This has a remainder. So it is not a factor. So that was a potential root, but it was not an actual root. So this one does not work. I would give up on this one and I would move on to the next one. So I'm going to do 2 next. But that's how you would use that P over Q. You would use them until you find the factor. So I'm going to try 2 next. Back at the drawing board here. And now that I did the synthetic division, this has a remainder of 0. So now we know this one is a factor. And so that's good. I've taken it from the x to the 5th to the x to the 4th. Now, we still can have several different solutions that come out of this. And so I'm going to go ahead and tell you -3 is another one. So we're going to go ahead and use that one so I can show you how it continues to go down. I would now use these right here to get it lower because that one was already a factor. We've taken it down. No point in starting back at the beginning. Whoops, I said that and then I didn't write that. And so that's another factor right there. And so now we took it from the x to the 5th to the x to the 4th right here, and then this would be x cubed. So we've got x cubed minus 2x squared plus 4x plus 8. The reason why I went ahead and wrote this out here is because I recognize that these numbers right here are greatest common factors we are possibly going to be able to take out of there. So we should probably be able to factor this by grouping. And so we're going to review grouping from Algebra 2. I group my first 2 terms and my last 2 terms. And so I'm going to factor out this x squared. And x squared times x gives me that x cubed. And x squared times a -2 gives me that -2x squared. I factor out a 4 from my second one, and I'm left with x. Oh, that was a -8. What was I doing here? -2. There we go. Caught that. Both of these are going to be the same when you're factoring by grouping. So now that they're both the same, I can factor out that x minus 2, and I get x squared plus 4. All right, so our complete factorization here. We found that this was one of them, so x minus 2. We found that -3 was a second one, so that's x plus 3. And now we found x minus 2 and x squared plus 4. We have completely factored that polynomial now. That was a hard one. You're probably not going to get anything that hard on your test, but I just wanted to show you how you make the list of P over Q, which is all the possible solutions, how you start to test them to figure out whether they are solutions or not. You use that remainder theorem to make sure that the remainder is 0 for a factor. And then we reviewed even some factoring by grouping here. So there's a lot of stuff that went in there. If you wanted the solutions, that would be the ones that make it 0. So 2 minus 2 would make that 0. -3 on this one, 2. And then this one's even an imaginary number. We're going to get more into that next class period. But we could review real quick what you did do in Algebra 2. You would set this equal to 0, subtract that 4, and then take the square root. And so anytime you take the square root of a square, you get plus or minus, and the square root of -4 is 2i. Anytime you take a square root of a negative, that's going to give you an I. So here we have 1, 2, 3, 4, and 5 solutions. So we have found all of the 5 solutions for this polynomial. It has 3 real and 2 imaginary. All right, that was finding our real solutions. Next class, we'll be doing the complex solutions.